Okay, good morning, everyone. Let's get started now. My name is Andrew. I am recording this on Zoom. I will be posting these lectures online, so please be aware that if you log on to Zoom, there's a camera right there, so you are being seen. Please be aware of that. If you have an issue with that, let me know. Otherwise, let's get started, and then let me know if you're working from home today. If you can't hear me, those kinds of issues, just shoot them in the chat, and then I'll be sure to address those accordingly. So my name is Andrew. I'm a fourth year PhD student here at UCR. My research is in water. I do photochemical denitrification, which basically means I use ultraviolet lights. I shine the water and then I turn nitrates into just gaseous byproducts, and then I investigate the water quality. If you're interested in research, love to talk to you guys about that. How many of you guys are chemical engineers? Most of you. Environmental? Okay. Anyone else? Any other majors? So only chemical and environmental, no materials, no mechanical. All right. So like I said, I'm a chemical engineering student. I graduated in 2018 here at UCR. I took this course with Dr. Barsanti. Yeah, this class can be a lot of fun. I spent a lot of time reading your guys' introductions, reading what you guys expect about this course. My opinion, I think that's great. You guys are pretty much right on track. You have the right idea. This class is going to be some math, some coding, and engineering. So if you have no experience with coding, that's all right. So raise your hand if you took like C++ or you took an intro CS class. Most of you. Okay, that's good. Raise your hand if you never took any CS classes. So everyone knows Hello World. That's good. That's perfect. You guys will do just fine. And if you don't, that's fine too. So there's a lot to cover in this first week. We're going to cover a lot. I want to make sure everyone gets up to speed. Week one covers introduction, mathematical background, and introductory MATLAB. So that's a lot. So it might be a little bit overwhelming. So get out your laptops, get out your MATLAB, start to get it ready, and get out a pen and get out your notes, because you need to be taking handwritten notes for the equations and then MATLAB as well for the coding. So have you guys heard of Notion? Have you guys heard of Notion? Do you guys use Notion? It's kind of like, raise your hand if you've seen Notion. Yeah, I love it. I love Notion because you can do commands, and you can take class notes. So let's say this is lecture one. This is week one. Lecture one. It's totally free. You can download it after class, and then you can start to like take equations. You can write equations and then take your notes on Notion. So I highly recommend it. Not only can you do equations, you can do, this is going to be really cool. You can do code. So you can do, you can write code blocks. So I highly recommend Notion. And then if you use Notion for like your homework, it'll be really easy for us to grade, because then you can export it. You can export it as a PDF. And then when you guys submit your assignments, it'll have your code right there. I can see the code, and then you can put the output as well. So this is not required, but I just started using it last year, and I love it. It consolidates all my notes really nicely. All right, so let's get started. Yeah, there's a lot to cover, so we're gonna basically cover housekeeping. So most of you guys are chemical engineers. Raise your hand if you're a junior. Okay, raise your hand if you're a transfer student. Okay, welcome. Seniors, where are the seniors? You seniors? Woo! All right. So raise your hand if this is your first time at UCR? Welcome, welcome. Okay, raise your hand if this is your first time at UCR and this is your senior year, so this is your last year at UCR. Is there anyone like that? Okay, all right. And I'll be checking the chat as well, so don't mind me. Okay, the screen should be the objectives. So if you can see the objectives, then you're good. All right, so welcome. Seriously, it's great to see you guys. It's great to see half of your faces. I would love to see the whole of your face. We'll have to wait until next time for that. But it's great. It's been a long summer. It's been a long year. This class, like I said, it can be a lot of fun. It can be a little bit challenging. But if you have already your introduction to engineering courses, if you already have your CS10, C++, then you'll do perfectly fine. There's a lot to go over, so let's start with some housekeeping. Regarding attendance, there was some confusion. Technically, this class, according to the syllabus, there are no attendance requirements, but this is college. If you don't come to class, I mean, I don't know what to tell you. The more likely, the more times you miss class, then I won't see your face. I'll be grading your assignments. So if I don't recognize you, it's going to be kind of hard for me to convince, it's going to be kind of hard for you to convince me to give you extra points. So it's really in your best interest to come to class anyway. And Dr. Barsanti has all the right to change the syllabus. So I really wouldn't be surprised if there's a pub quiz or something halfway through the quarter, things like that. So just try to make it. I know it's early, but it's really important for you guys to get this exposure and practice in person. And really, honestly, for me, it's just going to make it easier for me to help you out rather than going through the chat and doing that whole thing. I can just go directly. Yeah, so basically, there's a lot to go over. There's the introduction. I'll give you guys some tips for the quarter. And note that this is discussion plus labs. So that means that the first hour will be discussion, and I'll do an example problem. And then the next couple hours will be the lab, so you guys practice. So first, there's an example, and then we get to practice. So there's a lot to go over, and I know it might be overwhelming, especially the first week, but trust me, if you guys get through this week, it won't be as overwhelming next week. And then we'll go with the flow. We'll get used to how this structure goes. Sound like a plan? All right. Are there any like burning questions before we get started? No? Ready? So everyone has notes and everyone's ready to go? All right. So this class is numerical methods. The textbook is numerical methods for engineers and scientists, 3rd edition. Like a lot, this is a pretty great book. The lectures will be posted online, either on Canvas or YouTube. How many people would prefer Canvas? How many people would prefer YouTube? How many people want both for whatever reason? Both? How many people think one or the other? I don't care, as long as you post it and share the link, that's fine. Yeah? All right. That's what I was hoping for. I think I'm gonna go with YouTube, just because like that's just easier for me, and then I can share the links. If you have any issues with making it public, let me know. Otherwise, for the first week, I guess I'll make it like private for this class so you guys can watch it. If you have any issues making me making it public, let me know. And the reason I want to make it public is because some of my colleagues are interested in attending the sessions as well, and I can just simply share the videos. All right. So this is your textbook. Then you'll have the lectures. I probably won't be sharing the code. So make sure you pay lots of close attention when I do the code. And if anything, remember that Google, that's going to be the best resource, honestly. That can have anything. Yes, Cassandra has a question. Go ahead. Yes, go ahead.
Sorry, I don't have a question. That was just me raising my hand.
Okay. All right. So just so you know, I'm going to unmute you. So if you speak, then the whole class can hear you. All right, let's continue. It will probably be easier if you put it in the chat as well. All right. So last week, someone asked, what are the things that you should refresh on regarding the math and regarding the engineering? So I saw you guys' responses. Seems like everyone took calculus. So if you took calculus, you're more than fine. We won't even be doing a lot of calculus, honestly, but it is a prerequisite. We will be doing differentiation. We will be doing integration. We'll be doing that on MATLAB numerically. And so you'll be exposed to different elements of different advanced math classes, such as linear algebra. Does anyone know what MATLAB stands for? Yes? Good, good. Matrix laboratory. So linear algebra deals with matrices. Linear algebra deals with a lot of things. So that's going to be like good if you've already taken it. Raise your hand if you've taken linear. Some of you. I'm guessing, like, was that challenging? Was it okay? All right. The other stuff like vectors, multivariable, you might see it in your book, probably won't have homework on it, probably won't get tested on it, but you'll definitely see it in your other classes. Raise your hand if you're taking fluids this quarter. Yeah, you're gonna be seeing lots of this stuff. So this is more for you guys for your other classes. And then for your chemical engineers, you're gonna see a lot of all this stuff again in your senior year, process control, process design, separations, all that, all right? So expectations versus reality. Like I said, I saw your responses regarding your experiences. Seems like you're pretty good on the math, maybe a little bit variable on the programming. That's perfectly reasonable. So the expectation is that this class, with regards to real engineering systems, is combining mathematics, programming, and engineering to solve real world engineering systems. That would be a little bit ambitious. It's probably going to look a little bit more like this: a little bit of programming, a little bit of math, lots of engineering. So the way it's going to work is you're going to have some engineering problem, and then you're going to use MATLAB, use the mathematics to solve that engineering problem. Make sense? Okay. So like I said, this lecture has a lot. We're covering all of chapter 1, all of chapter 2, and the appendix. So it'll go by quick. Raise your hand if you have access to the book. Raise your hand if you started reading the book. Okay. How is it? Good? Yeah, this book is really great. Lots of examples. All the code is there for lots of examples. The practice problems are really fun. They take inspiration from chemical engineering, of course. There's civil engineering problems. There's statics, electrical engineering. So if you want to challenge yourself and you think that this course is going by too easy, definitely go into the back of the chapters and start to do those problems, because they can be a lot of fun, very challenging, and you can learn a lot for your future classes. All right. So I would like to call on a volunteer to read this, please. Don't be shy. In particular, I would love to call a girl to read this, please. Do we have any takers? I know it's a lot. Yes? Thank you. May I please know your name? Dixon. Thank you so much.
In terms of the variables, which is a problem of numerical solution. Solutions are approximation, in many numerical methods, the calculations are executed in an iterative manner.
Okay, so what did you guys get out of that? What does that mean? So who can give me an example of an analytical solution? Anyone? Yes? Yeah, great. So an exact number, an analytical solution is just a direct number. It can be an equation, it can be a model, a function. Newton's second law, F equals ma. That's a analytical, it's a model. It can predict what? What can Newton's second law tell you? Force balance. Okay, so doing force, equilibrium. What else can it tell you? So physics, right, is the overarching branch of mechanics. There's statics, there's dynamics. So you might have like force on a plane, right? Or you might have projectile motion. And what's the interesting thing about Newton's second law? Is it is it an algebraic equation or a differential equation? Raise your hand if F equals ma, if it's an algebraic equation. Raise your hand if you think it's a differential equation. Why is it a differential equation? Very good, very good. Acceleration is what? The second derivative. So if you have derivative, that means differential equation. So let's do an example. This is straight from the first page of your book. So I'm getting you started on the reading. We have a block, the force balance on the block. So I'm going to give you 5 minutes to try to derive the relationship between the force and the angle. We won't be doing physics. This is only for the first day, so don't get scared if you haven't studied physics in a long time. But just go ahead and spend 5 minutes writing down what you think is the relationship between the force and the angle. Feel free to talk amongst yourselves. I highly encourage you to meet with each other and work together on homework. So talking is good in this class. This is discussion. So what's the first thing you should do? Draw the free body diagram. Okay. Draw the block. What are the forces acting on the block? Normal force, friction, gravity, weight. What is the equation for gravity? M times G, pointing downwards. Which direction is friction pointing? The opposite of the force. And then the last force is the given pulling force. Okay. So that angle Q, you want to solve for that angle Q. They put Q, but I'm gonna give away the spoilers now. So we assume this is an equilibrium, right? Summation of all forces. Raise your hand if you've taken statics. Okay, so sum of all forces equal to 0. So you assume that the block is not accelerating. The horizontal component, set it equal to the horizontal component, right? X-axis. Vertical component, which axis? X, Y. Set that equal to each other, do some math, you'll get this equation. So force equals, what is mu? Coefficient of friction, mass times gravity, divided by cosine theta plus mu sine theta. That's what the book got. And so we want to solve for the angle required for moving the block, which can be determined by solving for theta. So write down that equation. In other words, suppose I give you force. Suppose I give you 1 Newton and the block is whatever, 1 kilogram. Gravity, you know, gravity. I give you the coefficient of friction. Doesn't matter what the numbers are. I just want theta. Theta as a function of force. So try to algebraically manipulate the equation, try to solve for theta as a function of force. Raise your hand if you think you have the answer. Any comments? Okay, so I kind of lied to you. So what's going on here? What's your thought process going on right now? Yes, it cannot be solved analytically. So there's no function, there's no trigonometric function. So what's going on with the cosines and the sines? What are you guys trying to do? Yeah, you're trying to like factor out that theta, right? Can you factor it? No. So this equation cannot be solved analytically, but it can be solved numerically. It can be solved numerically via iteration. So how would you do that? How would you solve this numerically? Any ideas? So you guys are all engineers. Let's say for your future job, your task is Mr. or Mrs. Engineer. I want you to solve for theta analytically. I will give you $100,000 if you can solve for theta numerically, excuse me. Any ideas? So the clue is via iteration. So what does iteration mean? Yes? Very good. So you can guess. Iteration means guess and check. First step is guess. Second step is, okay, iteration means guess and check. So the premise of this class is to learn how to solve this. So hopefully by the end of the class, you can use MATLAB to solve this equation given all these variables. There's many ways to do this. Yeah, so you can guess it, you can plot it. There's numerical methods for this. You can use for loops on MATLAB. There's many ways to solve these numerical methods. Remember that modeling is all about having equations as predictions. And remember that all models are wrong, but some are useful. So let's talk about the, what equation is this? ideal gas law. So can I have someone on this side please tell me what are some of the assumptions of the ideal gas law? So number one, you're assuming the gas is ideal. What does it mean for a gas to be ideal? Incompressible, very good. Any other guesses? Constant? Could be, it could be, yes. That's a very good one. So there's no chemical interaction between the gases. So you're assuming perfectly inelastic collisions. So the ideal gas law, the way it was derived, the physicists, the mathematicians, and the chemists back in the day, they said, hey, what if gases are just billiard balls and they just happen to collide with each other? I know that's not what's really happening. I know it's way more complicated than that. But what if they just happen to be doing that? Then they got that equation. What's the issue with that equation? There's errors. Why? Sorry? Very good, very good. There's no such thing as an ideal gas. There's no such thing as an ideal gas. All models are wrong, but some are useful. Has anyone taken advanced thermo? Yes? Okay, very good. So if you haven't taken advanced thermo, we'll go over all of these assumptions. What are the assumptions of the ideal gas and how can you make this better? Engineers are cool because we take the models that the scientists and the mathematicians invented, we tweak them, we make them a little bit more complicated. Have you guys seen the van der Waals equation of state? Yes? In your classes or not yet? Okay, so the van der Waals equation of state is another model that tries to expand upon the ideal gas law, make it a little bit more real. What you learn in advanced thermo is that apparently the ideal gas law is very, very accurate as long as the pressure is around 1 atm and you're not dealing with too many gases. So the ideal gas law is going to be perfect for your labs, for quick estimations, for your tire pressure in your car. Ideal gas law is a great, great model. But there are other models that are even better, but they're even more complicated. So now, again, if I paid you $100,000, I need you to solve for that A term. I need you to give me that temperature. I need to know what is the temperature of the flue gas exiting the stream, because we need to sell this chemical and the client is demanding what the temperature is. And so you're engineers, so you're getting paid to solve problems. Make sense? We on the same page? Any questions so far? All right. So therefore, this class is not a programming class nor a math class. It's numerical methods. So you're using programming, you're using MATLAB, and then you're solving engineering problems. You're solving numerical methods, okay? All right, so one study tip I have, this goes for any class. I call it, actually this is from Dr. Myung. Call it the plus minus method or above and below. So suppose your homework assignment is to go to chapter 4 to do problems 1, 10, and 15. So you're gonna do problems 1, 10, and 15 first, right? And then once you're done, you submit the homework assignment. You do 1 and 2, because your midterm, let's say, is next week, you want to study. You're gonna do problems 1 and 2. You're gonna do problems 9, 10, and 11, and then 14, 15, and 16. Make sense? And then you keep repeating that process, ideally until they touch, and then you do all the problems in the book. That's the name of the game. That's the best. That's a good study tip for engineering, which, as you can imagine, can be very time consuming. But the more you do, the more likely you are to increase your grade in this class. All right, so that was the introduction. We covered basically chapter 1. I want you to read this by yourself. Next, we'll cover mathematical background. And like I just said, I want you to do the problems. So the appendix, this one is really helpful because this class is all about MATLAB. So these practice problems will help you get a feel for how to read the language, solve the problems, write your own variables, that sort of thing. Okay, time for some numerical methods. Are there any questions about what we just talked about? All right, so go ahead and keep your notes out, but start to get MATLAB ready. We're just gonna jump right into MATLAB. There's a lot to cover. We'll just start slow. The user interface, operations. There's vector declaration and variable declaration. matrix computation, plotting, anonymous functions, user-defined functions, and also importing Excel data. And so if at any point you feel that you're not sure where to find something, remember, Google is your friend. All right, so let's get started. I'm going to open up MATLAB online, and all right, so you guys raise your hand if you have this screen in front of you on your own computer, on your own system. So most of you over here, most of you over here. All right, very good. So let's talk about the interface first. So let me make sure that we're good in the chat as well. Seems like we're good. All right. Okay, so let's talk about the user interface. Here we have the command window. So this is where you can write commands. Down here is your workspace, where you will see all your variables, all your functions, anything that is defined in your script. Here is your current folders directory. So what I want you to do is, if you haven't already, make a folder on your desktop, call it ENGR118, and then open that folder. And then make another folder, call it week 1. Okay. So it should look something like this. It'll load your C drive or whatever drive you're using, and then into your folder. And then you can separate it out by the weeks. You can separate it out by the type of function. Whatever type of organization system you decide, that's up to you. All right. So I think the way that we'll try this out will be, I'll try an example, you try an example. I'll do another one, you do another one. So the first thing we want to check is to just make sure it works. So type DISP, hello world. Make sure it works. Raise your hand if this does not work. And then if you don't have MATLAB yet, I'll be helping you one-on-one get started, installing and whatnot. Okay, are we good? We're good with Hello World? Perfect, we're ready for this class. So there's lots of things that I wanna tell you about. So the first thing is gonna be CLC. CLC means you're gonna clear the command window. So that's just gonna be like, all right, this is too much stuff, I just wanna clear it. And then that'll just clear the command window, kind of like clearing your calculator. Okay, so MATLAB is a giant computer. It's a giant calculator. So, you know, when you're like taking an exam and you're doing like these really hard problems, you're doing your calculus, you're doing your differential equations, but then you have something like, oh, 15 plus 7. I really want to make sure that's correct. Oh, okay, all right, we're good, we're good. Okay, so make sure you do the operations. So take a minute, do addition, subtraction, multiplication, division, subtraction, addition, multiplication. Do your powers, do your square roots, do your fractions. Yes. Sorry? Yeah, so if you have any questions, raise your hand. Totally, questions are good. So what is square root? SQRT. We can do a really big one. Okay, so square root, exponential function, exponential e to the x. It's too big. What other trigonometric functions? Sine 45. Okay, so with trigonometric functions, it's going to assume that you're in radians. So sine of 45 radians. If you want degrees, sine, d for degrees, 45 degrees. Okay. What else do we have? Fractions, just use division. We have fractions. Am I missing anything? That was all of like what? First grade through, high school. Okay. And then I'm going to clear the command window. I'll wait a little bit. You'll see. All right. So next thing I want to do is variable declaration. So who can tell me what a variable is? Variable in mathematics, the x, solve for x, the unknown variable. Computer science, is there another definition for a variable? Sorry? Very good, very good. So a variable is a string. So what's a string? So a string is like a char, a character. So it can be any character. So I'll just say A. So on the left-hand side of the equal sign, that's the variable declaration. So I'm saying A equals 5. So now A equals 5. So notice that in the workspace, we have the variable declaration, and it's reserving the value of the variable with the name A equals 5. Make sense? And then now we can, yes. So to clear the command window is what? CLC. To clear the variables is clear or clear all. That will clear all the variables. Okay? So that's going to say delete all the workspace. Okay? So go ahead and start to define your own variables. And remember, you can have any string. So I can say A equals 5. I can say B equals exponential of 15. I can say C equals A to the B. I'll do A divided by B. I can say be any string, any set of string. I can say cupcakes. I have 50 cupcakes, right? So any set of variables, define it however you like. Make sense? So that way, MATLAB can be super useful for all your chemistry assignments, all your engineering assignments, because you have lots and lots of variables, rather than doing everything by hand. Now you learned how to do it on MATLAB. Okay? So that's the command window. What I want to do is, I don't like using command window because you might delete stuff, you might clear the variables. So what we'll do is go into our folder and we're going to click new script. Okay. So this is going to be new script. We have a new, this is just like a file. This is like your Word document from MATLAB. So the command window, you can write your commands. And then here, you're going to write your commands in a specific order. Right. And then let's just check if it works again. DISP, hello world. All right. Run that. We need to save it. Yes. Live script has different features, so it's actually useful to take notes using the live script. Up to you whether you want to use one or the other. They both should work. With the scripting, it's just up to you. It's preference. Yeah. So I'm going to call this example 1. So you know how computers work. If you don't do exactly what they say, you get errors. So don't start with numbers. Don't do that. Don't have like weird symbols. Don't do that. Just do example 1. Example 1. If you want to use underscore, that can be a space. All right. So that should work. Here's our output. Are we good so far? Pretty good? Awesome, awesome. So what I like to do, this is preference. I like to just always start by clearing all the variables, because if I load a script from a previous assignment, it's gonna load all those variables, and then it might get confused if I have the same name in two different scripts. And then I also like to just clear the command window every time. So now we have all this junk right here. So now if I run this, so every time it will only output whatever I wanted for that script. The number is what, I'm sorry? The number is 1, 2, 3, 4. You're talking about this? So the way I did that was, I'm currently on MATLAB Online. I made a folder, this, Introductory 118, and then week 1. Okay. Is that your question? Not quite. Okay. Yes. These rows. Okay. Okay, now I understand what we're looking at. So 1, 2, 3, 4. So your question is, what are these numbers? These are the rows. These are the lines. So before we continue using scripts, let's actually jump into Google Sheets. Is that okay? Let's jump into Excel. MATLAB is great for your classes. Excel is great for your classes, for your projects, and for your labs. They're both really good. For this class, try to stick only with MATLAB. For your other classes, up to you. So the question was, what are those rows? It's the same as here, 1, 2, 3, 4, right? So we have all these rows. And then similarly, we can do the same things that we just did in MATLAB. Let's make sure that they work in Excel as well. So I'm going to define A, right? This is 15. Let's see if we can define the variables. Let's just say A, let's say this is pressure. Let's say this is volume. Let's say whatever this is, 10, this is 50, something, right? So do we know how to do equations in Excel? So we take this, multiply it by that, and then that's going to be our answer. So basically, Excel will give you that grid view, and then MATLAB will give you all the code nice and precise. So this is a row or a column? Everyone please pay attention to this. This is probably this is what MATLAB is about. This is about matrices. So is this a row or a column? This is horizontal, so it's a row. Is this a row or a column? Very good. So these are rows and these are columns. So rows and columns are examples of arrays. And arrays are examples of vectors. Who can tell me what is any of that? What is an array? What is a vector? Yes? Yes, yes, yes. So arrays are a set of elements. So I want to give you guys sets of elements. So let's say, what do we want to do? Like money, this is your amount of money, right? And then on the first day, you have $0, and then you make $10, and then you make $50, and then you make $100, but then you lose some money, so you make $20, and then maybe you make it big and you make $1,000. So this is an array with 6 elements. Okay, is a column vector. All right, just because I don't want to retype a bunch of numbers, I'm just going to do the same thing. Let's say this is people. Let's say this is, I don't know, pressure of the gas, right? So this is your column vector. This is your row vector. So what is this? That's your matrix. So now we understand what matrices are. Matrix is just the table. It's the table in your Excel. Vectors, 1 dimension. Matrix, how many dimensions? 2 dimensions. Rows, comma, columns. Rows, comma, columns. Okay, are we good on matrices for now? All right. Any more questions? All right, so far so good? All right, so I'm going to tell you how to define a vector. So I'm going to declare a variable, which is a vector. So let's call it vector 1 equals bracket. Let's start from 1 and we want to go up to 10. Okay, so I'm initializing the vector at 1. The default spacing is 1 space. So this is going to be counting from 1 to 10. Vector 1 equals 1 to 10. So when I display the output, before I display the output, I can either use the percentage either to comment this out. So now this is a comment, or I can suppress the output by adding a semicolon. So if I add a semicolon, MATLAB will do the calculation, will calculate whatever you tell it to do, and then it will suppress the output. I will suppress display hello world because we know it works. Check if MATLAB runs hello world. Declare, define a vector from 1 to 10. So what is going to be the output? Okay, so we have the vector 1 as the output. And then we can see, this is the nice thing about MATLAB. Now it plots it in Excel too. See? One to 10. All right. If I add vector 1, let's say vector 2 is the transpose of vector 1. So the single quotation means transpose the vector. What does it mean? What does it mean to transpose? Yes, you're inverting the columns and the vectors. So right here, do we have a row vector or a column vector? Vector 1. Vector 1 is a row vector. So now the single quotation is going to transpose it. So we're going from horizontal row vector to column 2. Vector 2 is a column vector. Let's run this. And we see the output. So vector 1, 1 to 10. Vector 2, 1 to 10. Any questions so far? So far, so good? You click the variable declaration. So this is why your workspace is super important. You can see all your variables right there. Okay. Now what I'm going to do, I'm going to suppress. Why is it important to add comments? Why is it important to add comments? Yes. Yes, exactly. You're gonna hear me talking about it. You're gonna hear your colleagues talking about it. What was this code? I wish I wrote a comment. Next time I'll write more comments. So always, what just happened there? Always add comments. All right. So now what I'm going to do is define a matrix. So M1, M1. And then, I'm going to just, instead of retyping vector 1, I'm going to redefine another vector, is V1, vector 1, right? So define V1 as the name for vector 1, just the same name. And then now what I can do is define a matrix. So what is a matrix? How many dimensions is a matrix? 2 dimensions. So let's say I want the first set to be V1, and then I want the second one to be 2 times V1. Okay. So if this works, we should have a matrix displayed. And as you can see, MATLAB outputs in order columns 1 through 14 and columns 15 through 20. So this is actually still a vector because we need to add a semicolon. So when you're defining a matrix, the semicolon is going to enter a new line. So do you see how this is a, so what is this? Is this a vector or a matrix? It's a vector because it's one dimension. So now what I will do is I will output this semicolon. Do you guys see that semicolon? So now the first vector horizontally, enter new line, second column horizontally. If this works, then we should see M1 update. And there's our results. Okay? Now what I want to do is I'm going to suppress that, and then I'm going to transpose it. I'll just say MT is the transpose of that. Let's just see what that looks like. All right. So is M1 the same as MT? Yes or no? No, why not? What are the dimensions of M1? Who says 2? Who says 2 by 10? Raise your hands, 2 by 10. Who says 10 by 2? Okay, so the way that MATLAB, everyone memorize this. By the way, you can add if you do double percentages, you can have sections. This is section 2. Hopefully you guys can still see that. Section 2. And then it divides it nice and easily. So MATLAB displays, let's type notes together, right? MATLAB displays matrices as rows, comma, columns, not columns, comma, rows. Okay, so the rows, your horizontal, columns, vertical. So we have 2 rows, 10 columns. As you can see, this is 2 by 10. Sorry, let me write that. Okay, I'm going to give you 2 minutes for a, actually, no, we don't have time. Let me just quickly show you. Let's do section 3 is plotting. Section 3 is plotting. All right, so to plot, how do we plot stuff algebraically? So in your high school class, in your algebra class, how do we plot stuff? Can someone give me an algorithm in which you will plot a function? Let's say I want to plot the function f of x equals x squared. How would you do that? Manually. Okay, set up a table of values. So what is the defining feature of a function? One input, one output, or multiple inputs, one output. The inputs are going to be what your input variable is, and then you have a single output, which is going to be the function itself, right? So the first step, step 1, declare a vector as the input variable. Okay, so how do we do that? Let's just say x. Let's plot the function f of x equals x squared from 0 to 100. So what does that look like? First of all, do we have an idea of what to expect? Right? Yes? Good on that? So declare the vector. So let's start from 0 to 100, right? So 0 up to 100. I'm going to suppress that. I'm going to run, make sure I don't have any bugs here. Things seem like I'm good. What's the second step? Step 2 is to you guys can read that? Step 2 is to, let's say, calculate the value of the function at every point, right? So how do we do that? F of x. If we write f of x equals x squared, you're going to get some bugs. So let me just tell you what to do for today. I'll just give it a variable name, f of x, or I'll say, let's be really precise. Function equals x squared. So this is a really long variable name, just to make sure we know what we're doing here. Function equals x squared, and we're going to type x. And then here's the tricky thing about MATLAB. The following is one of the reasons that CS majors hate MATLAB, but engineers love MATLAB. We have to add a dot, so we calculate this value element by element. X dot squared. Okay. So now we have x, and then we have f of x equals x squared. Okay. I'm going to say optional. Replace name because it's too long. F of x equals function equals x squared. Suppress the output. Let's make sure it runs. Should be good. What's the last step? Step 3 is plot the function. So this is the reason why, as an engineer, I love MATLAB, because we only needed 1, 2, last step, 3 lines of code, x comma f of x. We only need 3 lines of code to plot a function, whereas in other languages you need several lines of setting up, defining the variables, defining the output, defining the graphical interface, and then you can get started with plotting functions. MATLAB gets rid of all of that for you, and you can only do everything in 3 single steps. Step 1, declare your variable, declare your vector. Step 2, calculate your function. Step 3, plot the function. Run that. Figure 1, and that's our function. Do we agree? Is that what we're expecting for f of x equals x squared? Okay. So now it's time for your lab. I was originally going to do this example for you, but I think you guys will be good. I think you'll be good, and I want to get started helping people set up. So go ahead and open up MATLAB Grader, get started on this assignment. Sorry, one sec. Before we get started, let me go over what this example is. We have defining variables. We already talked about variables. Defining the function that we're calculating, and then calculating the output. MATLAB Grader is going to be a little bit finicky, but I'm hoping it will be way better than any other homework system you use. I'm trying to make it real. So I make the problems. So I'm going to try to make them really easy. There's unlimited attempts. So you can attempt them as many times as you want. The only catch is you have to declare the variables in the names that I specify that you'll read. It'll show you. That's the first problem. My recommendation first is to, you read the problem, read the assignment, and then try MATLAB on your computer. The goal is not to understand how to use MATLAB Grader. The goal is to use MATLAB. And then MATLAB Grader is just the software, the interface to upload your assignments. So try it on MATLAB on your system and then upload it directly. We covered a lot today. you have any questions, well, I'm about to address those. And then pop quiz. Okay, pop quiz. What are some good resources for this class? Textbook, Google, me, peers, professor, YouTube, me again, textbook, other textbooks. Don't limit yourself to just this textbook. What else? Pretty much that's everything. Google, Google. All right? I heard that. Your second problem is adopted from 3.30. So notice that in the actual problem, it asks you to calculate volume. So I switched it up, made it a little bit easier. I'm giving you volume, calculate pressure. You should be good. So like I said, I'm giving you the value. I want you to store it into these variables, P sub ideal and P sub van der Waals. Plot them on the same figure. So I think I gave you all the tools necessary. At this point, I'm going to be helping you guys out. Any questions? All right, go ahead and get started. And then let me know, I guess like come up to me if you need help. Like, let me go to you actually, or like setting you up. Very interesting.